Hi everybody, it's Kyle Cordes again at Oasis Digital with part 2 of my series about Cycle.js, how and why it's worthy of some attention. Don't be alarmed, even though I work at Oasis Digital where we do vast amounts of work with Angular, nonetheless I am interested in other technologies including this one, hence this video. For a quick recap of where we were from the first video, this is the repository that has the example project that I'm going through and kind of using as the context to point out some things that I find real interesting. And this is the running program. I have it running here locally. I have a window here where I have it up and running with just npm start from what's in that repository if you feel like following along. And I can look at the code right over here. So to recap where we left off, I had just explained this chip component. This component statically displays basically something like this, like the word color chip, a label, then a big block of color. So it statically displays that. We had previously seen a component that just statically displayed some content but didn't take any inputs. This chip does take inputs. Now it takes inputs, but a single chip is here, and this overall thing I'm looking at here, this is several chips. So let's take a look at the code for a set of chips, and the thing I've called chips tsx. Now we saw this file briefly last time, but set it aside to pay attention to the individual chip component within it. So let's look at this overall chips components now. So as usual in Cycle, there's great concision. A cycle component is simply a function that takes a set of sources and returns a set of sinks. So here I have a cycle component called chips. It takes a set of sources and it returns a set of sinks. Now, this overall set of chips doesn't take any inputs at all, so it doesn't define such a need, and it only outputs some visual appearance, some DOM. So this is all we have, no inputs and one output. In here, I wanted to pass some data into these chips. The way this works with Cycle, the answer is always an observable stream, and so I have some data, and I want to make that data available to pass into a subcomponent. How should I package up that data? Well, we're in Cycle, so the answer is always an observable stream. So here is an object that I'm using to drive my red chip, which is this first chip. So I'm just telling it the red's 240 and so on. The label is the word red, and I need to make that an observable stream. And again, pointing out this X stream, which is this sort of lightweight, crisp, observable library, kind of super well suited for Cycle. They simply say xs.of. For RxJS fans, that would be the same as observable.of, except that you don't need to go through kind of any of the push-ups to make it available. It's just immediately available. You'll note that I only did 2 of these because I had brushed over there is a default coloring available in the chip component, so even though I'm using 3 chips, nonetheless, I only do 2 chips here. Okay. There's a lot of complexity in understanding what's going on with this part of Cycle, but there's amazing simplicity to the code that's going on. So I'm going to try to just explain just enough of that to make it make sense. So the chips. This is a section of virtual DOM that I have in mind embedding in this overall page. And the way I've chosen to represent that is it's an array of virtual DOM things, but this is Cycle. We always use observables, so it's not just a single instance of one of these virtual DOM trees, it's a stream of them. So we will gloss over this isolate thing for a moment. What we have done here is we have a view function. We've talked about view functions before. I decided to pass it an array of things to put inside itself, so chunks of other component to display inside. And just to show that when you're using Cycle, like you manipulate components just as variables in TypeScript or JavaScript. Like there's nothing special about them. They don't have a special elevated place. They don't have to be registered with any kind of system-wide mechanism. They don't need to be annotated. They're very, very lightweight, direct TypeScript things in Cycle. So here I am making this stream, or this, I guess, yeah, this array of streams. I forget how to get that right. If the brackets were inside the angle bracket, then we would have a stream of arrays, but they're outside. We have an array of streams. This isolate mechanism, I think I could have actually skipped this here because I don't actually need isolation for these, but isolate is part of the standard pattern you use with Cycle, and you can read about this on the Cycle website. It's part of the standard pattern for using one component inside another. So if I want to use the chip component inside another component, inside the chips component, the way I do that is I call isolate on the chip, and then that isolate takes that function, which is a chip, and returns another function with some isolation. We'll have to go you have to go much deeper. I'm not sure if I'll even get there in this series, but there's a lot to understand about that isolation behind the scenes. But basically, this is a way of saying, put one of these in a sandbox so it can have its own stuff, its own state, and its own everything. So we're saying make one of those and then give it some sources, right? So this right here will return a component function. And the way you call a component function, if you recall, is you always call a function passing it a set of sources. So we're going to pass it this set of sources. Now, where are we going to get sources to pass it? It so happens I just know it only needs this props thing, but you really shouldn't rely on that with Cycle. You should assume that whatever sources were passed into you as a component, by default you want to pass into child components and make available. So here I'm simply using the TypeScript or JavaScript, I guess ES7 object spread syntax to say, take the sources I was given and then mix in this props thing. And so this props thing is simply that guy. So the red $sign is simply an observable series of objects, of which there's actually only just one, which is the kind of the props to make the thing red. And so this word props matches this word props right here. And again, if you note this matching is not happening through any kind of mechanism Cycle provides. This is literally, I'm taking this function, translating it to another function with a function, then I'm calling that function and passing it an object that includes a thing named prop. So there is no framework in between point A and point B. And I found that to be different than most other web app development toolkits on the kind of virtual market as it is. Okay, so the thing that came out of this was a component. The only part I care about this component is its virtual DOM, its appearance on the screen. There are reasons I could care about other parts, and we'll probably see some examples later, but the only part I actually care about on this one is the DOM. So I take that chip component definition, I make one, I give it this set of values that tells it how to be read, and I hold on to its DOM. Same for another one that's gray, and then same for another one where I just let it take the default, so I don't pass it any special props. So now I have this array of streams. Now, I probably could have or should have started with an even simpler example of composition where I only put one component inside another, but for the sake of getting somewhere useful in a small number of steps, I've jumped to this relatively complex use of how I could use one component inside another. Apologies. Okay, so at this point I have this chips. This chips is an array of these streams of VDOM, and if you think about it, a stream of VDOM, that just means like an appearance on the screen, which could change over time. You can essentially do anything that's going to display on the browser. So anything you can imagine putting in a chunk of the browser screen, you can express as a stream of VDOM, and that expresses how it looks now and how it continues to look the same or different over time. Okay, so DOMs here, so this is simply the same array as this, and I happen to know that that TypeScript type inference will get me where I want to be, so I didn't have to sit here and like type, apply types to all these things. I can even hover and I can ask the IDE to tell me, so this is pretty slick. So it knows that this type is the same type that's there, and then similarly if I hover here, that's interesting. There is something less than amazing about the typings behind the scenes, because I know a thing it doesn't know. Like it should be able to reason about the type coming out of combine here. It should be able to tell me what the type is of chips, but the typings are not as perfect as they should be. They'll probably continue to get better with time. Okay, so out here I have just 3 streams. By passing them to combine, now I have one stream. So combine, you give it essentially an array of streams, and you get back a stream of arrays. So at this point here, I have a stream of arrays, and now I call the map function. Now the map function on a stream gives you a context to put a function inside that'll receive the actual values. So this chips is going to be an array of VDOMs instead of an array of streams of VDOMs. And so then when I compose the overall appearance of the page here, I'm saying, okay, give me a pure grid. I'm using this pure CSS framework just for variety. I usually use either Bootstrap or one of the material implementations, but this time I picked up pure CSS for fun. So I'm saying make a div, that goes to here. So make a div called pure-g for the grid system, and then these, like that's a grid column, that's a grid column. You kind of reason out what these probably mean by their names, and then inside the one on the left, I'm simply going to pass in these three things. Now this is one of the slickest bits about Cycle, is that I didn't have to use any like frameworky mechanism to compose the appearance of one component into another. So the VDOM, the appearance of this thing, I simply used language features, not library or framework features, to compose the first thing in that array, which is the red one, in here. And of course I could rearrange these. Let me see here, I'll save that, and then I don't remember if I have auto reload set up. Yeah, there we do, I guess I do. So there you go. So now I just rearrange the order of them. So that's how you can tell that it's really executing here. It's not fake, it's legitimate. Okay, so I think I've explained pretty thoroughly what's going on here. As I said, there's some subtlety with the isolate, and technically speaking, I probably could get by without the isolate. So let's do just a little bit there. So I'm going to try it. Oops. I'm going to try it without the isolate. And I'm not going to worry about that type problem. I think I would actually work without the isolate. Let me just make sure I didn't. Yeah, I didn't get any errors when it recompiled. So I didn't technically need to isolate here, but it's just generally a good practice when you use one component inside another with stream. So I stuck with that good practice. Okay, so here we are in video 2. We are up to 12 minutes, so I think that gives time to explain just a little bit more. So let's look here at the application. So going to the next bit here, and again, I'm going to explain this navigation router mechanism at the end, because it's really quite a lot more complex than anything going on inside these things. So, okay, next I have a color picker. Now this is a super simple color picker. You can look at a well-developed, finely crafted, iterated full color picker online. In fact, there's a fantastic video talk from a conference about that by a really sharp woman whose name I cannot remember right now, so sorry. But her implementation of a color picker is way more impressive than my implementation of a black and white gray picker, but nonetheless I think mine is useful for explaining because it's pretty simple. So if I click on this thing, you see each time I click on it, this value is going down. When I click on lighter, it's going up. And then there's a color chip here. It's not the same kind of color chip I have over here. It's like a simpler implementation. It's displaying a swatch of color. So this is a very, very simple component. You can probably imagine how to implement this in Angular, React, or whatever other development tool you've used. You can probably imagine implementing something like this. Let's look at how this is implemented in Cycle. Okay, so this time it's just a single file called the gray picker. Boring name for a boring component. And I'm going to just, as usual, explain the code kind of piece by piece and what's in here and why. Okay, so first I said this line of code occurs almost every time, almost every Cycle component, because you almost always need to talk about the stream capabilities and then the name of the type that a stream is. And this is Xstream. If you've used RxJS, you're familiar with the ideas, but many of the syntaxes are different, and Xstream is a narrower set of features. Next line, we want to talk about cycle DOM here. You know what? I can actually do some cleanup. There's no reason these need to be separate lines. So here we go. The next line is just some DOM. So this is some appearance. So to talk about the appearance, I'm going to need to have like a stream of vnodes. Vnodes are like the container of any kind of virtual DOM. DOM source is the type of a thing, and we'll see that type of a thing come into play in a minute. And then there are many syntaxes you can use for virtual DOM here in Cycle. They all come from SnapDOM that I mentioned last time. The syntax I've chosen in this component, you call functions that correspond to the HTML element you want to apply. So if I'm using an HTML element, I call a thing called button, and those are all sitting in Cycle DOM. And there's various other ways to do it, but this is the way I did it here. Okay, next. Now we've talked about repeatedly, or I've talked about repeatedly, that a cycle component is simply a function that takes a set of sources and returns a set of sinks. Now this time, this is the first time that I've, going through the numbers here, that I have one that actually takes a source and cares about it. So this is some arduous syntax that if you haven't used TypeScript much, I'm going to spend a few minutes explaining this bit of syntax. So if you only look at this part I have highlighted, this is destructuring. So destructuring is an idea that gained popularity in the Clojure programming language a few years ago. It's just shockingly convenient. And for that reason, I think it's really starting to catch on across many other languages. JavaScript and TypeScript picked up destructuring pretty recently. Destructuring means instead of saying the variable kind of at the top of what someone's going to pass you or what you're going to assign, you can sort of lay out a template and say, here, this one means someone is going to pass me an object that has a field in it called DOM, and that field called DOM, that's the thing I want to capture and refer to. So I don't care about a reference to this whole thing as a parameter, I just need a reference to this thing as a parameter. So that's what this part means, simple destructuring. But this is TypeScript. We want the system to be well typed. We want all the code as we look through here to understand what the type is of this thing. And so the syntax here is kind of ugly. You end up repeating this name because this colon, this is not like a JavaScript object colon, this is a TypeScript type colon. So I'm going to get an object that has a field called DOM. That object I'm going to get is of type object with a thing called DOM, which is a DOM source, where DOM source is the name of a type. So this is the somewhat arduous syntax for saying I'm going to be passed an object that has a field in it called DOM of type DOM source. Please give me that field called DOM so I can refer to it in this function. So a lot of words for one line of code. Okay, next, some manipulation of observables. So this is, again, this is like observable of, if you're coming from RxJS. So initial $, we're following this convention most of the time where variables that have observables have a $. I think this is a common thing that happens when there's kind of an interesting new feature. I think that, well, pretty soon here, certainly if I do much more with this, I'm going to realize almost all of my variables are $signs. And why would I put a $sign on the name of almost every variable name? And I'm going to stop doing it. But for now, I'm kind of going along with the common practice of putting that $sign at the end. So initial $sign is simply an observable stream containing just a 128 in it, and that's all. So then that's the end of the stream. Let me. Yeah, I was gonna try. I thought I might try commenting out. I guess I won't. Okay. Now, this is kind of a wrinkle with Cycle, that often the code, you kind of have to read it backwards. So for me to make sense of this part, I really have to understand the view. And so unfortunately, I have to read this thing backwards, but fortunately, it's my own file and my own editor. So I will unbackwards it. There's nothing to stop me from doing this. So since I have to understand the view code in order to make sense of what, this is kind of conceptually the controller code, I'm going to put the view code first. So let's take a look. The only state in this component, by the way, this is the first component with state. The only state in this component is just a single number. Well, so this is Cycle. The question is, I'm in Cycle, I have a problem. How do I solve that problem? The answer is always with an observable stream. So I have some state. Where am I going to put that state? In an observable stream. In an observable stream. It kind of makes it easy to answer questions about Cycle. Sometimes I even wondered maybe try to get some points on Stack Overflow by just watching Cycle, when everybody asks a question, just immediately answer, you solve that with an observable stream. So the state of this thing is simply a number. And so because it can change over time, it's an observable stream of numbers. And because we're still kind of pretending that streams are a new special thing, we've named the variable with a $sign. So the whole state of this thing is a single number. And then when you call the view, you have to pass it that thing. And here it is. So to actually use that number, I need the number, right? I don't need an observable stream of the number. I need the actual number, so you do that with map. So I take val, so I'm going to map from a stream of numbers to a stream of the whole appearance of this whole thing. So basically this view function translates 128 to this entire rectangle of the screen. Okay, now this time I've chose to do it in the, I guess they call it a hyperscript like syntax. So this means that I'm not using TSX or JSX. I'm not typing angle braces. I'm not looking like HTML. I'm just doing this with functions. You'll see why that comes in super handy in the future. So basically this whole section here, it's a grid. So I need a pure G. This is like a bootstrap row essentially, and then a pure U23. This is like a bootstrap 8-column or something, and then the other half of it is like a bootstrap 4-column or something. So it's 1/3. 1/3 means 1/3. If I want a p tag in there, I just do this. I felt like pressing enter in the middle because I don't like terribly long lines of code. So I used a backtick string so I could press enter in the middle, and I don't even care if they're extra characters because they won't mean anything in the HTML that comes out. So this part is real easy to understand. Just to explain a few more little bits that I've glossed over so far, here's a div. There's a shorthand way of passing a string to set some properties that would otherwise be irritating to set. So for example, if you look at this button, I wanted to set its class to be a pure button plus, and in the button I did it kind of the long way. So I said make an object. The object has a field called attributes, which is itself the value of an object, which has a value called type. So this type becomes an attribute of the button, and the class becomes an attribute of the button. And that's a lot of JavaScript syntax. This is basically a shorthand CSS-like syntax mechanism that makes it super easy to make a div with a pure G class on it. So that's all this does. And then after the comma there, you give an array of all the stuff that goes inside the div. The slick thing about this is because these brackets match the indentation structure, I don't need a special tool that understands like HTML indentation because I'm using TypeScript language features to create my indentation. So when I do TypeScript auto formatting, I get auto indenting, and that happens automatically. No special support for cycle, no special support for snapdom or any of this. It's just a consequence of rather than inventing a new language, like rather than inventing a template language, we're just using the language we already have and we get a bunch of great features. So sorry for the sideline there. Okay, so on the left here we have the words gray color picker. That's obviously an H2 element. An H2 element, you simply pass a string with a payload that goes inside. And by the way, there's a bunch of variations I'm not showing here. I'm trying to intentionally use shortcuts to give a feel of what this is like to actually use rather than give documentation of how each piece works. So after the gray color picker, we have a button, we have a space that's inside a span, and that just stops the buttons from touching each other. And then we have another button, and then we display the value with a p tag, and then we have a div. So there's some little interesting pieces to show through here. So this button, you have to say button type button, or else your button ends up being a submit button, which is not usually what you want in a single page app. I wanted to have some classes on it. This class right here is real important, and this is kind of a really interesting edge of cycle. It starts to feel very slightly jQuery-like here, in that the conventional way to wire things up in cycle is to like take a button that you care about and put a class on it that will help you identify that specific button so you can catch its events later. And you could use an ID instead of a class, but that's the basic idea. So this means give me a button, button type equal button, class equals pure button and plus, and the payload of that button is the word lighter. So this This ends up being about the same number of characters as the HTML syntax would be for the same thing, but we'll see in a later numbered step here why there's some pretty slick advantages to that. Okay, so this is just a span with the space in it, the same kind of button. This time it's a minus as the kind of the identifying class. Then this P here, so check this out right here. This is just TypeScript or JavaScript. I can just take a string and say plus and put some number in there. So the thing that makes this number appear right here, this is not a template feature. I'm not using a template language. I'm not using any special features. I'm actually not using any cycle features. I'm not using any snap-DOM features. I'm just doing the kind of the simplest, most obvious possible thing here and saying, there you go. I mean, just take the value and just append the actual number onto the end of it, and that gets turned into a string. And then the next kind of the most interesting bit here is one of these things you can do inside this object is you can define your styles locally, and it looks like what I really need to do is here. I need to do a little bit better indentation. There we go. A little more obvious what's going on here. So this time on my div, I'm giving it some styles, width, height, and border. Oops, and then background color, put him down there. So width, height, border, and background color. Of course, I could have just done these statically with the CSS file, but I wanted to just illustrate a few more points. The point is here especially that this background color, I'm using JavaScript template string. So again, I'm not using a cycle feature, I'm just using built-in language features to stick some parameters in here. So I have this stream of numbers, and then inside the map function I have an actual number, and then I just drop those in where I want them. No special features were used. Okay, so this is a full description of this view. Now the interesting thing about this function is if you look only at this function and you disregard the stuff up here, this thing is very, very close to the kind of the minimum number of tokens that it would take to fully describe this view. There's really not hardly anywhere to go from here in terms of kind of noise or overhead. About all I can see that could plausibly be removed, and this is another topic of some discussion in Cycle, is that like I had to manually take care of taking the stream of numbers and getting an individual number out of it. And there's some discussion about whether this tiny bit of boilerplate right here is really a great idea. There's kind of an alternative fork, like friendly fork of Cycle that gets rid of this tiny, tiny bit of overhead. I haven't found it to be a practical problem yet, but I haven't built anything of any great size. But if like that's pretty small overhead, and then there's hardly anything here I can imagine removing that would still describe the HTML that's supposed to come out. And it's very concise, very crisp. I just don't have, like with our current tool sets, I don't have a way of saying any fewer things to describe this. I really think that actually might be a pretty fundamental challenge, actually, that this is still too much work, right? If I just casually describe this to another person, yeah, I just want a gray picker and just make a button to make it lighter and a button to make it darker and tell me the number and show me a swatch. Like it seems like I could describe this. There should be some more concise way to describe it, but this is really the most concise way that I've seen in a framework so far. Okay, so as I was saying, I intentionally swapped these around and started with the view function because there's stuff in the controller that refers to the view function. So getting back to where we were, I'd explained this hairy type. We got this stream called initial, which is just a single value. Now, this is where it gets really interesting. This line here is the first really interesting line that we've seen in 28 minutes of this video and 25 of the previous. So when it says DOM select, if you look, this DOM is this DOM. So this is the data coming into this component. The DOM down here is the data flowing out of this component with the view. They're named exactly the same for a reason, even though they're quite different things. The one coming in is the hook you get in a component to find out about things that are happening on the screen in the DOM of the browser. Now, you may think to yourself, I wonder what form this information will arrive in about what is happening on the screen, And this is cycle, and in cycle the answer is always, it'll come in the form of an observable stream, because that's the answer to every question in cycle. So if I say I want to look at the DOM and I want to pick things of type or of class plus, so this string right here is kind of a CSS-like selector. So take a look at anything that has the class plus, which we just reviewed is going to be this button, and get click events on it. Right? And guess what? That's an observable stream. And take each thing that comes down this pipe, and I don't actually care about the details of the data in the pipe, like the event, the actual click event, I don't care about. I just want to take that and make that into a 10. So if basically every time somebody clicks this one, this plus stream emits another 10. So initially, of course, it emits nothing because nobody's clicked on it, but then I click this and a 10 comes out. The minus works the same way. Every time I click this one, this pipe, this source of novelty, this stream, has a minus 10 come out. So I have an initial value of a 128. I have a stream that sometimes emits a plus 10 and a stream that sometimes emits a minus 10. Well, XS merge, that's how you just take several streams and just graph them all together. So this val $ says merge that initial 128. So there's this 128 flowing down this pipe, and then there can be some plus or minus 10s coming down the pipe. So as of this point right here in the code, I have a 128 followed by some arbitrary stream of plus and minus 10s, which is pretty slick. This is a fairly elegant representation of what's actually happening. It kind of handles the time aspect for you pretty nicely. But we don't want, like, I wouldn't want this thing to say 128 plus 10 plus 10 minus 10. I actually want to, get the number out of it. So to do that, I use another operator in the xstream library, fold, and I think this might be equivalent to scan in RxJS. I might be picking the wrong one, but it's not the same as reduce. Be careful with reduce. Reduce doesn't return till the whole thing is done. If you want answers along the way, you have to use scan in RxJS. Use fold in xstream to achieve the same thing. So fold is kind of it's like a fold function, very common from like any functional programming language. But roughly speaking, the function you pass it will be called repeatedly, being given an accumulator, which was the previous value, and a new value that has arrived, and the first value of the accumulator will be 0. So as soon as some data comes down this pipe, which will initially be a 128, this function will be called with a 0 in that position and a 128 in that position. And so it takes 0 plus 128, we'll get 128. And then I've put these math functions around it so that if you try to exceed 255, you can't get any bigger. And if you try to go below 0, you can't get any smaller. So in this sort of pretty concise code, I've said, take an initial value, give me a stream of people asking for it to increase, a stream of people asking for it to decrease, combine those into one stream, and then perform a mathematical fold with the addition operator. Pretty slick. Okay, so this val, that means that val is now going to be a series of the results of doing that, a series of numbers. That gets passed to this view function and creates this idea. Okay, so I had pretty high praise for this code, and there really is hardly anything that could be removed, but I feel like there are still some ideas to be discovered in terms of making this code maximally concise. I feel like there might be some things I could do just with some refactoring. So for example, if collecting button clicks is a thing that happens all the time, I could remove this duplication right here, right? So I could make either some helper function, or I could extend DOM source or something to make it super easy to get, kind of more concisely get that. So I might be able to reduce that. If I was writing this as production code, I would realize that initial is actually just about the same number of characters as the thing that it's set to. So I would have just taken this and I would have put it in there, if this was production code rather than kind of explanation code. So there are some ways to make it a little more concise, but I still feel like there are many more kinds of improvement possible down here. So, okay, so this concludes my second video, kind of talking about some interesting things I picked up, introducing kind of what it's like to build things with Cycle. I hope you've enjoyed it. Please point wherever down there, click that subscribe button to make sure you catch the next one, and I'll see you then.